My name is Doug Hoover. I'm a solutions engineer with the SAP Database and Technology Group. Today I'll be talking to you about the SAP Sybase IQ architecture. I'll only be discussing IQ 15 architecture, and IQ 15 has been released for about the last few years. IQ was designed to support complex ad hoc queries on massive amounts of data with many concurrent users. It was designed from the ground up to be column-based, storing all of its data in bitwise indexes, which actually deduplicate and compress the data. Multi-threaded and optimized for bulk modifications, so things like loading data, bulk inserts, bulk deletes, and bulk updates. IQ also uses page-level compression once it writes its data pages out to disk, gaining even more compression. IQ also has a multiplex plex queue architecture that allows multiple servers to access the same instance of the IQ database, allowing us to scale queries as well as support additional users. IQ is actually a complete analytics platform. It's much more than just a columnar database. So it has a columnar database. It also has in-database analytics. So it allows you to build analytics using C and C++ code and actually run those analytics directly in the query engine. It also has special text search indexes. These special text search indexes allow you to do comprehensive text analytics and searches. It also has communications and security built into it, so it allows strong encryption and authentication, as well as encrypting data in flight, and then it's also Web 2.0 capable. It also has many other APIs allowing it to communicate not only with standard ODBC and JDBC and .NET type environments, but also some of the more advanced analytic environments like PHP, Ruby, and Perl type environments. Let's kind of do a bottom-up approach here and start with the space allocation. You store database and the database objects on devices, and on all the different operating systems we run on, these devices can be operating system files or raw partitions. In a production environment, we suggest they be raw partitions, and in a multiplex type environment, it's a requirement that these are raw partitions. Each database includes multiple what we call DB spaces. A DB space is a unit of storage within the database that may be administered as a logical subset of the total storage. And then you basically allocate individual objects and sub-objects to these database spaces. And then a store is actually a collection of one or more DB spaces that contains persistent or temporary data for a special purpose. IQ has 4 different types of stores. The first store is called a catalog store. The catalog store contains the system DB space, and this is used to contain all the metadata for the database. So this is definition of the tables, columns, indexes, stored procedures, users, permission type information. Then the main store of IQ, called the IQ main store, actually contains 2 different types of DB spaces. It contains the IQ system main DB space, and it contains the user main DB space. The system main DB space contains structures necessary for IQ to operate, things like checkpoint logs, roll forward, roll back type information, as well as versioning type of information. And we suggest you do not create any user tables in the IQ system main. Instead, we suggest you create a user main DB space and store all of your tables and indexes in the user store, in the user main DB space. IQ also has a temporary store which contains the temporary DB space, and this contains all of your temporary structures, temp tables. And then with the introduction of the distributed query process, we also added the IQ shared temporary store, which has the IQ shared temporary DB space. And this is used for the distributed query process. So here's a graphical representation of that. So you're in a single node type server where we're not doing a distributed query type processing or any of the FlexQ type processing. You basically have your three main stores, your IQ main store, your catalog store, and your temp store. Your IQ main store would contain the IQ main DB space and the user DB space. The catalog store would contain the catalog DB space, and the IQ temp store would contain the IQ temp DB space. If you go into a multiple server environment, IQ is basically a shared disk architecture type environment. So you would still only have one IQ main store. So all of your user tables and all of your indexes would basically be shared amongst all the different servers. But each of the servers would have its own catalog store and its own IQ temp store. And the catalog store is actually kept in sync across all servers by the IQ multiplex software. 15.3 of IQ, we added the distributed query process. So now that we can actually distribute a single query across multiple nodes within a multiplex, we then add a feature called the IQ shared temp store. And this is used to actually share the results and merge the results of the distributed query back together. And then again, this is a single store that's shared across all the different servers in a multiplex. And then there's an option called a very large database option, this is Sybase IQ. With this option, you can actually create multiple user DB spaces. And a couple example scenarios for this is information lifecycle management, where you may want to use different tiers of SAN storage, say very fast SSD type storage, maybe just slightly fast fiber channel type storage, and then slower SAS type storage. And then partition your table so that the newer, hotter data is on the faster disk drives and the bulk of your older data that isn't accessed very often is on your slower, less expensive disk drives. Another scenario for this option is called a consolidated data marts, where we can actually store data for different applications in different PB spaces. That way that queries from against one set of tables can't affect performance of queries from another set of tables. Then here's the layout of the disks behind those DB spaces. So it's in the sizing guide, we recommend a minimum number of files based on the number of cores. So that's shown here by these DB files connected to your user DB space. So we recommend a minimum of at least 4 files. And then we recommend that each of those files be its own storage area LUN, and that you don't slice up a single LUN and spread it across multiple files, because IQ is actually striping the data across these files. So you don't need stripes across partitioned stripe devices. And the same holds true for the temp DB space as well. So the same ratio of cores to files. So now let's go up one layer to the actual server architecture and talk about logical servers and in-database analytics. So in a multiplex environment, or FlexQ type environment, we can actually have multiple instances of Sybase IQ accessing a single copy of the database. In this case, we can actually distribute queries across multiple servers to speed query response time using MapReduce as well as the optimizer within Sybase IQ. When doing this, we can actually control how many servers a particular query can run against using a concept of logical servers. So with IQ, we can actually define a logical server. So in this case, we have a logical server defined with 4 servers in it, different logical server defined with 1 server in it, and you have a third logical server defined with 3 servers in it. In this case, your distributed queries for one group would only be able to run across those 4 servers, where distributed queries for the other group would only be able to run across those 3 servers, and the distributed queries for the group in the middle would only be able to access that single server. And these configurations can be dynamic. So this could be Friday, last day of the month configuration for accounting, IT, and finance. And then once the month is closed, you could then distribute more of these servers over to the finance side and take a few away from accounting. Again, all dynamically without bringing down the multiplex. We also have built-in database analytics, as I mentioned in the first slide, so we can actually run analytics right in the database server. We have libraries of analytics available to do predictive analytics as well as time series analytics, or you can build your own analytics using C, C++, Java, PHP, Perl, Python. We also support PMML, so you can export your models from your analytic tools and run them right in the database engine. So in summary, we give you the ability to scale to meet any size database, any query speed, or any concurrent user requirements that you have. If you need more space, you just simply add more disk drives. If you need to speed up your queries or add more users, you then need to add more CPUs and memory or more servers to the configuration. Thank you. Have a nice day.